Okay, guys, so the question was, for the no reaction, all right, no, not reversible, you were supposed to draw a beaker for what happens initially, and then what happens finally. And you're supposed to do a particle level view, a magic school bus view, so either draw molecules, ions, formula units, or atoms, okay? And then you're also supposed to do it for the reversible reaction, okay? All right, I'm going to start with this one, okay? The biggest point, actually, June, can you tell me what you put in the initial beaker? Okay, H2 and I2. And he was kind of crafty. He was really thinking about it. He said, well, let's put the H2 up here because it's a gas, and let's put the I2 down here because it's a solid. That was pretty smart. Okay?
I drew this whole thing at the bottom
Because it was a solid. Good. Okay, and then somehow we get it to mix around, and then, okay, June, what'd you put over here for final? Surely you have a product, right? Do you have product?
Sure, you hope so.
Do you have some product? Okay. How many of you have this as your drawing?
Yes. Yeah.
Okay. June, what else did you have in your beaker?
Second one.
He also had some H2 and some I2. Okay? I don't know if it's 4 HIs. It doesn't matter. Let's not focus on that because it's actually going to form an equilibrium, and without that equilibrium constant, we don't know exactly the numbers, right? Okay? So the big point that I wanted you to see here is that because this is a reversible reaction, it forms an equilibrium. That means it never goes all the way to completion. Okay? Once you get it started, it's always going to have both reactants and products in your container. That's a huge point. Yes, Alex?
Shouldn't the HI be an initial as well to represent the reversible reaction?
Well, the instructions that I gave were that you were just starting with reactants.
Okay.
And that was the only reason. But you bring up a really good point. The nice thing about reversible reactions is you can start anywhere. You can start traditionally with just reactants, and that was kind of my instruction, so not a huge deal, okay? But you can start with all three things in there. There's no reason why you can't. You could also start with what?
Just one thing.
Just the what?
Just the product.
Just the product. If it's reversible, if we start with just product, it'll back up and it'll make those two, okay? The only thing you can't do is just start with one of your reactants. Like if you just started with hydrogen, you're going to get HI. No, that violates the law of conservation of matter, right? The law of conservation of mass.
Nuclear
Okay?
reactions.
But you can start from any point. Yes, Michaela.
So you said that it never reaches completion.
Right. It's not going to go all the way if it's reversible. It forms an equilibrium. That's the big point I wanted you guys to get between yesterday and today. Brandon.
You said that you could start with all three of them?
Yeah.
What do you mean?
Well, I mean, if you just threw them all in the container, if they were just all were there, it would still react because it would want to get to its nice balance point, its nice equilibrium. Last night you had to calculate like an equilibrium constant one time. It'll get to that point, so it might go more forward or go more backwards, but you could actually start with all three in there. Okay? A lot of the problems that you're going to be working, you start with some of this and zero of this, and then it goes, but it doesn't really matter. Okay? You good?
Don't
All
say
right,
that.
over here, does this one go to completion? Yes, it does. Okay, so let's start with our reactants. Now here, in addition to starting with reactants, I wanted to see if you guys remembered about what breaks up. What are the three things that break up in solution?
1A groups.
Let's go back one from that. Strong acids, strong bases, and salts that are soluble. And now, what kind of salts are soluble all the time? 1As, so that would certainly include sodium chloride. What else? Nitrates. And not sulfates, I think ammonium, right?
Yeah.
Those three are the ones you really are responsible for. I think chlorates are always soluble as well. So, tell me sodium hydroxide. How is this classified? That's a strong base. So we're going to have Na plus and OH minus. Okay?
Okay.
How about HCl? How do we classify that? Strong acid. So H plus and Cl minus. So that's what we have initially present. Yes, they're floating around in water. Okay? All right. Then, final, are we going to have our reactants left?
A little.
No.
No.
It goes all the way.
Oh, just kidding. It's not
Okay? It goes all the way to completion. So, we're going to have, tell me about NaCl. Is it soluble?
Yeah.
Yes. So Na plus and Cl minus. Tell me about water. Do I break it up?
No.
No, silly rabbit. Okay, H2O. All right? Amina. Yes, go out the back. Okay, so guys, I also want you to think about this. Is there a spectator ion in this reaction?
Yeah.
Which one would it be?
Define spectator ion.
Cl negative.
Someone, can one of you guys define spectator ion for us?
A spectrum ion is an ion that.
You go so far.
Thanks.
Say it again, Star.
I mean, it just, when something is soluble, it just sort of, it doesn't participate in the reaction, it just sort of sits there.
Exactly. It's not a team player. It's not participating in the game.
It
or
rides the
reaction.
bench.
It's on the bench, or it's just spectating. It's just watching. So,
Be OH.
well, look at what doesn't change at all. And so there's actually two spectators. Na does not change at all, and Cl does not change at all. That means they were not really in the game. They were not really in the reaction. They're just hanging out. And so the real, if you think about our net ionic equations, we had H plus, OH minus, making H2O. Okay? All right, so the big takeaways that I wanted you to get from this is that this goes to completion, so we definitely see reactants and then products, and this doesn't go to completion. So here we're seeing everything because it's forming an equilibrium. We're not given enough information to really figure out the ratios, but that's okay. I just wanted you to conceptually see that everything is there. Got it? Okay, good.